Dear students, good morning. Hope you all are fine and safe at home. I, Miss Shaheen, is going to teach you Science 1. When you will see the index, there are 10 lessons in Science Part 1. Today we will study something interesting, that is Chapter 2, Periodic Classification of Elements. First question that comes in your mind after listening to the name of the chapter: why there is need of classification of elements? So answer is, as there are 118 elements known to scientific world, to study each element's properties and characteristics will be difficult. Classification is the best method to arrange the group of elements showing similar characteristics or property, as we have studied in previous class about classification of plants. Let us see few questions to recall previous knowledge. First one, what are the types of matter? We know the types of matter are solid, liquid, gas and plasma in physical state. Second one, what are the types of element? The types of elements are metals, non-metals and metalloids. Third one, what are the smallest particle of matter called? We know the smallest particles are called atoms. Fourth one, what is difference between the molecules of elements and compounds? Students, we know elements contain only one kind of atoms in free state or combined state. A compound is produced by chemical reaction of two or more elements. And elements cannot be decomposed into simple substances by any chemical reaction or simple physical process. Example, copper, iron, oxygen. The constituent of compound can be separated by chemical process. Example, salt, water and sugar. We all know matter can exist in form of elements, compound and mixtures. When elements were discovered, a proper classification was required for easier and better understanding. However, around year 1800, only about 30 elements were known. More and more elements were discovered in course of time. More and more information was gathered. Many scientists adapted different way to classify them. They tried to find out some pattern or regularities in the properties of elements. The first among them was a German scientist, Johann Wolfgang Dobereiner, who in 1817 found some group of three elements which shows similar chemical properties. These groups were called as Dobereiner triads. Children, here if we have a look at triad table, he arranged three elements in a triad in an increasing order of atomic mass and showed that atomic mass of the middle element is approximately the mean of the atomic masses of the other two elements. Student, as you can see in the example, mean of actual atomic mass of lithium 6.9 and potassium 3.91 is equal to actual atomic mass of sodium, that is 23. Similarly, the triad is obeyed in few more examples like chlorine, bromine and iodine. Student, as this classification was primitive step, Dobereiner could identify only some triads from the element known. Other triads did not obey the rule. Examples like nitrogen, phosphorus, arsenic. Children, when you calculate mean atomic mass of nitrogen 14 and arsenic 74.9 is not equal to atomic mass of phosphorus, that is 31. Hence, the system of triad was not useful. After the failure of Dobereiner's triad, the next attempt to classify elements was done by British chemist John Newland. By this time, 56 elements were discovered. He arranged all these elements in increasing order of their atomic masses. Newland found that every 8 element had properties similar to those of the first. He compared these octaves found in music. Therefore, the classification was known as Newland's octave. Example: 7 sargam, like sa, re, ga, ma, pa, dha, ni. The frequency of notes goes on increasing from sa to ni. Then comes the sa of the upper saptak. It means notes repeat after completion of one saptak. Similarly, it was compared with 7 notes in the Western music are do, re, mi, fa, so, la, thi. Children, when you see in the table, 8 element fluorine is showing similar properties like first one hydrogen. Many limitations were found in Newland's octave. This law was applicable only up to calcium out of 56 elements known, after which the element did not show similar properties. Also later, several new elements which did not feature Newland's classification were discovered. It means it do not follow the law, that is, 8 element was not showing the similar characteristic as first one. There are few demerits in the table. When you see the table, he placed 2 elements each in same box: cobalt and nickel, cerium and lanthanum. He placed some elements with different properties under same note in the octave. Example: Newland placed the metal cobalt and nickel under the note do, along with halogen, that is chlorine, bromine and fluorine, while Fe, which means iron, having similar characteristics with cobalt and nickel, was placed away from them along with non-metal, oxygen and sulfur under the note Ti. Hence, Newland octave failed. After the failure of Newland's octave, Dmitry Ivanovich Mendelif, a Russian chemist, put forward a periodic table that was called Mendelif periodic table. Student, let us see more about scientist Dmitry Mendelif. Between the year 1834 to 1907, which means 1834 was his birth year and 1907 was his death year, he was a professor in St. Petersburg University. He made separate card for every known element, showing its atomic mass. He arranged the card in accordance with atomic masses and properties of the elements, which resulted in the invention of the periodic table of elements. During the period 1869 to 1872 AD, Mendelif examined the relationship between the atomic masses of the elements and physical and chemical properties. These were the molecular formula of hydrides and oxides of the elements, melting point, boiling point, and densities of the elements. Hydride means a binary compound of hydrogen with another element. Similarly, oxide means a binary compound of oxygen with another element. Mendelif arranged the known elements in the increasing order of the atomic masses and their properties. Therefore, he created the first periodic table containing 63 elements, till then known as Mendelif periodic table. On the basis of that, he states the law that the physical chemical properties of elements are periodic function of their atomic masses. Mendelif periodic table. The horizontal rows in the periodic table are called as period. There are total 7 periods. The vertical column in the periodic table are called as group. There are 8 groups from 1 to 8. In Mendelif periodic table, the general formula of oxide for group 1 is R2O, for group 2 is RO, for group 3 is R2O3, for group 4 is RO2, for group 5 is R2O5. For group 6 is RO3. For group 7 is R2O7. For group 8 is RO4. R in Mendelif periodic table means general element. As you can see, the example of oxide for R2O is Na2O. RO2 is SiO2. RO is CaO. RO2 is CO2, etc. Similarly, it is applicable with hydrogen. RH4 will become CH4, RH3 will become NH3. The merits of Mendelif periodic table are: Mendelif kept some blank spaces in this periodic table. The vacant spaces were for the elements that were yet to be discovered. He named them Eka-boron, Eka-aluminium, and Eka-silicon. And also he predicted their properties which later were found to be correct. They were known as scandium, gallium, and germanium. When noble gas were discovered, they were placed in the Mendelif table without disturbing the position of other elements. Mendelif periodic table have its own demerits. No fixed position could be given to hydrogen in the table as it resembled alkali metals, that is group 1 elements, as well as halogen, that is group 7 elements. At certain places, an element of higher atomic masses has been placed before an element of lower atomic mass. Example, cobalt 58.93 is placed before nickel 58.71. So, some element placed in same subgroup have different properties. For example, manganese Mn is placed with halogens with totally different in properties. Due to this irregularities, a need for new classification thus emerged. In 1913 AD, Henry Moseley, an English physician, discovered that atomic number is the most fundamental property of element and not its atomic mass. This discovery changed the whole perspective of elements and their properties. Accordingly, Mendelif periodic law was modified in modern periodic law, which state that the chemical and physical properties of elements are a periodic function of their atomic number. The periodic table based on modern periodic law is called modern periodic table. Students, today we have studied elements and their classification, Dobrynia's triad, Newland law of octave, and Mendelif periodic table. In next lecture, we will be studying about details of modern periodic table. Hope you all understood the topic. Thank you everyone. Stay home, stay safe.